thank you everyone for coming here for this session. I'm really glad. I know that many people have said this today. I'm very glad to be here in person to be able to present this. So thank you to OCP, the organizers, and of course, Wiwynn. So I'm Raghavan Venugopal. I'm the Executive Director at Wiwynn, and today I'll be presenting about our product portfolio strategy that extends all the way from cloud to edge, and how we build our designs using modular approach. So let's get going. The philosophy that is the glue that drives us in our product portfolio is driven by 4 trends. The first trend is the power density. The power keeps increasing, and thereby power density per U or per chassis or per rack is also going up. So that is a key trend that we see, and I'm sure you all are seeing that as well. The next trend that we see is the processor choices are going up, are exponentially increasing, which is, as a consumer, as a buyer, is great, as a supplier is great. However, when it comes to maintenance and serviceability of all these different processor choices that are going to be available in the market in 5 years from now, if we don't make the right choices now, it's going to be a nightmare. So one of the items that we're going to talk about here is about maintainability and serviceability that comes with these different kinds of processor choices that we have. The third trend that we see is processor core density is also increasing, core count is increasing, which means that there is a potential for realization of more resources, more efficient usage of resources. So we'll talk more about that in that trend. And then the fourth trend is 5G. So we're seeing 5G, we're seeing a lot of applications on 5G. So what are we doing about that? That would be the fourth trend. So these 4 trends are what are the 4 categories that we here, we're presenting lots of workshops and content, and all of them would be associated with these 4 trends. And we have categorized 3 of the topics, like 3 topics in each one of these trends. So we're going to go over 12 topics in this session. Okay, so the first one, power density continues to rise. And what that means is we need to have creative solutions to cool. And these 3 topics that you see here is around those creative solutions that we have built. The first one is a workshop. It's about ORV3 blind mate liquid cooling IT gear that we will be co-presenting with Facebook. The second one is a white paper that we've developed and we've contributed. And this white paper is about liquid cooling integration and logistics, the design guidelines. And then the third one is actually very interesting. I think this would be of use to anybody who wants to understand about 2-phase immersion cooling. This is not just about theory, this is actually our learning. And we have a panel that we are co-presenting with Microsoft about our learning on immersion cooling, 2-phase immersion cooling. And that's also going to be there. So these are all the 3 areas that would be available, and I will go into a little bit of detail. And if you want more details, of course, you can go into those workshops that will be having these. So from a ORV3 blind mate liquid cooling IT gear, this workshop, so what you see here is basically a chassis that was built for air-cooled. It goes into an ORV3 rack, OpenRack V3 rack that's air-cooled. Now we got to turn this chassis to be able to fit into liquid cooling. And the components that you see here, the hose guides, the plug side, the socket, the TTV module, the injection module, all of these, the system manifold, all of these were built by Wiwynn. And these are the different components that make this chassis ready for liquid cooling. And this is what you will be seeing in that workshop. Okay. So the second one is the guidelines for immersion cooled IT equipment. So as you know, all the equipment that we have today, all the IT gear that we have today is based on air-cooled. And what this means is all the materials that we use around IT gear is all suitable for air-cooled. Now, we take this same IT gear and we are immersing into a new technology which uses a fluid, and we use two-phase immersion cooling to cool the same material that was earlier built for air-cooled. So there are lots of challenges in this, and we want to understand what those challenges are and how to overcome them, how these materials react, how these materials need to be handled, how the fluid need to be handled, in order to have a safe and in order to ensure a safe operation of the immersion-cooled IT gear. So that's basically what we've converted into design guidelines, and that would be available as a white paper in this document. So the next item here in the first trend is about immersion cooling, two-phase immersion cooling. And here, the journey for Wiwynn started almost 3 years back, 3.5 years back. The first phase of this journey was to understand about the technology aspects of immersion cooling and baseline the different variables and the knobs that are important for immersion cooling to function optimally. And that was the first phase. The second phase was to take existing air-cooled hardware and to immerse them in the technology that we know now works, and try to have a baselining of performance comparisons between the air-cooled system and the immersion-cooled system. And that's the second phase. And the third phase, which is where we are going next, is basically to build purpose-built hardware that would work even better, taking advantage of this immersion-cooled technology. So that's the third phase. And what you see here in this panel is all the learnings that we went through. As an SI, we are very proud to have built this first tank. It's a 38U tank. It's capable to cool 17.4 kilowatts of power. We built this tank from ground up, so it's a Wiwynn product. We also see the need for an SI to have the capability to understand about this technology, and that's why we spent our resources in R&D to build this tank ourselves, so we can be a vertical integrator, because we know about servers, we know about cloud, we know about our customers who are in the cloud, so we can take all that learning and apply it into a new technology like immersion cooling, and that's why we built this building block ourselves. So the journey, the challenges that we saw in this journey is basically material selection as far as the tank itself goes, the ability for manufacturing it in the factory, how the factory needs to be redesigned, how the DC needs to be redesigned to make sure that these can be deployed properly. And then once it is deployed, the commissioning work that happens during the deployment, and then once it is running, what kind of failures, what kind of monitoring we need to be doing, and what kind of root cause analysis and failure analysis that needs to be run. All of that is going to be in this panel. So if you are a little bit interested in this technology, I would certainly request you to be part of this panel that we co-present with Microsoft. So those are the three in the first trend. Now we go to the second trend. The second trend that we see is the processor choices are increasing. And like I said, as the processor choices increase, 5 years from now, if we don't make the right choice point for management framework, as these proliferation is happening, we're going to have a nightmare on our hands. We're going to have a hard time servicing all these different configurations because each one of them would be unique. But if we want them not to be unique, and if we want them to be easily serviceable, then we need to make sure that the framework that is used for management is common and can be easily scaled across different processor configurations and different processor families. So basically a framework and a firmware framework that is processor agnostic. And that's basically what we're trying to do here. The first one you see is pros and cons of integrating a modular BMC design, what is called as the DC SCM. It's the data center ready secure control module into a server. The second one is OCP server, Delta Lake, OSF. OSF is the Open System Firmware. And this is actually the first server that we have contributed to OCP. It is an OCP server that also has Open System Firmware. We'll see a little bit of detail in the next slide. And then finally, we also talk about, again, the challenges that we face when we completely change from the UEFI BIOS into Open System Firmware BIOS. Some of the challenges that we face and some of the solutions that we specifically addressed is presented as a white paper in this last section. So the first one, this is, again, the journey started 2.5 years back. We started as a concept. We built a first modular design, basically taking a monolithic motherboard, which is what the norm is today, and breaking it into two components, the host processor module and the DC SCM, which is the data center ready secure control module, and then standardizing the interface between them. And more importantly, taking all the firmware components out of that host processor module into the DC SCM. And what this does is it turns the hardware, it turns the host processor module into just a hardware. There is no firmware to it. And since the interface is now standardized, the development and the validation of the host processor module becomes separated out from the system development. So it's a key answer to the challenge of the cloud timeline. We heard a little bit in the keynote today about cloud timeline, which is like every year there is a new product offering, and that is a cloud timeline, versus an enterprise timeline is like 2 years, or an ASIC timeline is 2 years. So we have a cloud timeline where there are new products, there are new processes that are going to be coming out in every 12 months. And in order for that to keep up as a system designer, as an SI, we need to make sure that we have a component that is common across all these different changes. And that's what this does. Again, there were challenges. We now have a product that's going to be available next year, starting next year with DC SCM. So we have some challenges. With any new concept, not everything is going to be rosy. We find out some challenges that we have to overcome. So in this workshop, we would talk about the challenges that we've faced as well, and about the positives. The positives, of course, cost, time to market, validation, and then the disaggregation between the firmware and the hardware. All of those are the positives. Okay. The second one is the OCP server Delta Lake OSF, how-tos and features. Again, this workshop is going to showcase the OCP server. It's a Yosemite v3 server that is going to be, it has already been developed with OSF, and we'll showcase the feature set, and we would compare that against the UEFI BIOS and show that it is feature set compatible. And like I said, this is something that we have contributed back to OCP. Again, a proud moment for us to give back to the community with this product line. Again, this journey, the OSF journey, also started with us first starting the development with Intel Broadwell, and now we are on the third stage. Where there was Intel Broadwell, then there is Skylake, and then there is Delta Lake. And there is a future to it. We are already looking at Sapphire Rapids. So that's the fourth step. Now we are on the third step. As we started, we were doing just the basic, IPMI, ACPI, just the normal baseboard config stuff on the first step. The third step, we are actually now doing security, RAS feature, performance tuning. So all that is already available. And in Sapphire Rapids, we're going to have even better. It's going to be CXL ready. It's going to have all the memory features that comes with Sapphire Rapids. So, it's the timeline and everything about OSF looks pretty interesting. Okay, so the Open System Firmware development on OCP platform. This is a white paper, and why this white paper is important is, again, with OCP branded servers in March of 2021, the requirement has changed for any OCP branded server to be compatible with OSF firmware. So with that diktat, with that change in requirement, some of our partners started using Core Boot and Linux Boot as their open system firmware architecture. And as they gravitated towards Core Boot and Linux Boot, they found out some deficiencies that they did not see in UEFI. And what we did here is basically try to implement IPMI connection into Core Boot and Linux Boot. IPMI, as you all know, is very important. It basically helps us manage all the assets inside the chassis. So if we can integrate IPMI and make it successful for OSF, we believe that that's a great opportunity and also what we can give back to the community to make sure that OSF becomes successful. Okay. Now to the third trend. So processor core count increases, right? So as processor core count increases, we see that there is a potential for higher utilization of resources. So what this means is, we have a 1P system, Yosemite V3, that's a 1P system. And what we see here is like what we talked about earlier. This 1P system is able to cater to multiple use cases. A 1P system usually used to be a low-end server with only very simple use cases, but now we are able to use that same 1P system for many use cases. And as we start to use these 1P systems for many use cases, again, we need to have a common framework that is very important. And so the management of that 1P system becomes important. And that's what this workshop would be talking about. How do we have a common framework, making sure that our BMC is divided appropriately where the commonality between all these configurations is maintained? Okay. So the second one is the improvement of OAI system management. And then the third one is, we have a live demo on the record-breaking power density. It's 3 kilowatt in 1U. This is another immersion cooling showcasing that we're doing. It's a mid-level immersion cooling tank that can cool up to 6 kilowatts. So let me go into detail into one of these. So like I said, I think I went into the detail of this one already. So let's go to the second one. So the OAI is OpenAI system. And this OpenAI system, what we are doing here, how we are contributing here is by taking our DC SCM and trying to fit it into this open OAI system. And making sure that the OAM's UARTs are streamlined. So we're basically taking the existing design and trying to map it into a more streamlined version, and also being able to provide the DC SCM support into the OAI system. So those are the things that you would see here in this presentation. And in this third one, certainly if, again, you're interested on 2P, two-phase immersion cooling, this is something that I would strongly recommend that you go to this booth. It's a live demo. It shows the OAMs that are built using Habana GPUs. So basically, Habana GPUs are on an OAM board, and 8 of these are in that board. And it's a very high power density system. Right now, it's around 3,000 kilowatts in a 3U air-cooled space. Now, in this immersion cool system, we've taken this 3U and converted it into 1U. So we basically reduce the dimensions. And on the other 1U, there is a server. And all of this is inside a liquid stack tank. And this one is really phenomenal. You should go take a look at this. And we're basically able to cool up to 6 kilowatts in this tank. The coolness about literally the coolness about the two-phase immersion cooling is that we would be able to cool up to 4,000 watts in 1U. And with the PUE of 1.01 or 1.02, so this is, compared to all of the technologies that are present today, this is the best. Okay, 5G. 5 more minutes. So 5G becomes pervasive. The first one is OpenEDGE. It's basically the 5G becomes pervasive. So what does that mean? It means that data centers are going to go disaggregated, smaller data centers, widespread data centers in different locations, not necessarily all homogeneous environment. So all these are challenges that comes with 5G. So to address these challenges, we need to have systems that can work to overcome these challenges. And the systems that we are going to be talking about here is the EP100 and the ES200. And in this first topic, what we have here is a rack management solution by Wiwynn. Again, just like how we have the BMC, this is a rack management solution. The second one is we are contributing this design specification back. This is a white paper that talks about the details about this rack management solution. And the third one is the spec of the ES200 server itself. So the first, the workshop here would talk about the rack management, would show you the rack management solution. The rack management solution, basically you have multiple sleds, and then at the chassis level, you have the chassis assets, the fan and the power supplies, and you have to manage all these assets, the chassis assets and also the sled assets, which basically the BMC is managing for the sled. So the rack manager needs to communicate with all the sleds and also manage the chassis assets. And that's what the rack manager is doing. And then it needs to pipe all that information to northbound traffic using Redfish. So what we have done here is use all open standards, and we have a rack management solution that is functioning, and that is basically part of our EP100 solution. This one, again, this goes into the details of the rack manager specification itself, so that's available as well. And then the last one, the ES200, is basically, again, this is a 2U server, and it is specifically for AI on the edge and also MEP on the edge. So there are different applications when it comes to edge, the CU, DU, core, AI, MEP. So CU, DU, core can be taken care of by our EP100 platform. And then the MEP and AI can be taken care of the ES200 platform. And basically, these platforms are short depth. They have multiple sleds, multiple configurations, good level of PCIe expansion capabilities, and robust. They're built for different environments. And what you see here is also cool, is another one of our immersion cooling tanks, but that one is the entry immersion cooling tank, which can cool one of the ES200 sleds. So it's a really cool small tank that can cool one node of ES200. And we did this just to showcase the ability of the technology to basically reside in any hostile environment. And so will be there in our booth if you want to take a look at it. Okay, one more minute to go. Last slide. Wiwynn is a platinum member. We've been part of this community since 2010. We love OCP. We love to contribute to OCP. We love the partnership. We enjoy coming here. After 2 years, we've been able to come back. So we enjoy coming here. We enjoy showing our work. Thanks to most of our team members. Jenny has been our pride star, who was able to pull everything together. So thanks to all the team members to make this happen through multiple challenges. So from an OCP standpoint, we have 22 OCP accepted products. We are the #1 OCP rack provider. We ship 10,000 racks every quarter. So, significant amount of OCP gear that gets delivered through Wiwynn. And then we are in multiple OCP projects. You name it, compute, storage, edge, OpenRMC, OpenBMC, everything, we are there. And then finally, we love to work with partners. We love to engage partners in different countries, in different regions who support OCP. And that's it. Let's go sell more OCP hardware. Thank you. Thanks a lot.